In this video, we will discuss interpreting measures of dispersion. A main use of dispersion measures is to compare the spread of two or more data sets. For example, two companies sell 12-ounce jars of instant coffee. 5 jars of each were randomly selected from markets, and the contents were carefully weighed with the following results. Coffee A, the jars contained 12.02 ounces, 12.08 ounces, 11.99 ounces, 11.96 ounces, and 11.99 ounces. Coffee B had weights of 12.40 ounces, 12.21, 12.36, 12.22, and 12.27. Find A, which company provides more coffee in its jars, and B, which company fills its jars more consistently. To determine which company provides more coffee in its jars, we look at the mean. So X bar sub A, the average amount of coffee in the jars for type A, is 12.008 ounces, while X bar sub B is 12.292 ounces. And because X bar sub B, the average amount of coffee for jars of type B, is greater than X bar sub A, we infer that company B likely provides more coffee per jar. To determine which company fills its jars more consistently, we look at the standard deviation. For each sample, a smaller standard deviation means there is less spread in the data and implies more consistency overall. The standard deviations are S sub A, the standard deviation for coffee type A, is 0.0455, and S sub B is 0.0847. Since S sub A is smaller than S sub B, we infer that company A seems more consistent. Chebyshev's theorem. For any set of numbers, regardless of how they are distributed, the fraction of them that lie within k standard deviations of the mean, for k greater than 1, is at least 1 minus 1 over k squared. So for example, what is the minimum percentage of items in a data set that lie within 3 standard deviations of the mean? By Chebyshev's theorem, with k equals 3, 1 minus 1 over 3 squared is 1 minus 1 over 9, which is 8/9, or about 88.9%. The coefficient of variation. For any set of data, the coefficient of variation measures relative dispersion. It is calculated as follows. V equals S over X bar times 100% for a sample, or V equals sigma over mu times 100% for a population. So for example, compare the dispersions of samples A and B. And this is, we've got samples. Sample A is 12, 13, 16, 18, 18, and 20. And sample B is 125, 131, 144, 158, 168, possibly, I think that's 165, and 193. So if we take X bar sub A, that's 16.167. S sub A is 3.125, and V sub A, the coefficient of variation, is 19.3. For B, X bar sub B is 153.167. S sub B is 25.294, and V sub B is 16.5. Sample B has a much larger dispersion from sample A, given its larger standard deviation, but sample A has a larger relative dispersion based on its coefficient of variation. The dispersion within sample A is larger as a percentage of its mean.